Yo.
So looking at this sheet right here, this is a quick review of adding, subtracting, and multiplying polynomials. Also using the vocab that you learned in Algebra 2, being able to name the polynomial by the degree, and being able to identify how many terms are in it. I also would like you to start practicing saying what the leading coefficient is, which is not on there, but we're going to do it together. You should be well versed on this page. This shouldn't be too much of a review, which is why I just threw it at you to see, go ahead and start what you know. I bet some of it starts coming back to you as I go over some of them. So let's look at it. So at the top, it's name each polynomial by degree and number of terms. Terms are separated by plus and minus signs. So if you look at these examples, you can see clearly, you draw the slashes if you need to. This has two terms, and it is not in standard form. Standard form would be the degree that is the highest. That term needs to be in the front. That is called your leading term. And then the number in front of it is called your leading coefficient. And then, of course, that 2 is positive, so it would come after. So that is considered standard form. That is a two-term polynomial, which in short we call binomial. This has 4 terms. It is, again, not in standard form. You would do, it's like a cup game. Y'all know the cup game? 3 cups, ball underneath, and then they shuffle them, and you have to guess which one it's under. This is like a cup game of shuffling these 4 terms around. The sign that's with it would stay with it as you're shuffling, and you would write it in descending order by the exponents. You would say that is a 4-term polynomial. The leading term is 10r to the 4th power. So the degree, which means highest exponent, in this case is 4, which means it's called a quartic polynomial, or you can say degree 4. You do need to know constant, linear, quadratic, and cubic. That's 0, 1, 2, 3. Anything higher than that, it's safe to say the actual number. You don't have to call it by a fancy word. 3 through 6 is practicing adding and subtracting. There's a little bit of a caution here. A lot of people tend to see parentheses and they immediately start multiplying. Be careful. The parentheses are there just to say, hey, take this crap and subtract that crap. So that's what the parentheses are for. There is, when it's, let me move over to 4. When it's addition, like in this case, this is addition, it's as simple as finding the like terms and just combining them. Like terms have to have the same variable, same exponent, every time. So b cubed, b to the 4th, nothing, nothing, b to the 4th, b cubed. When I'm throwing complicated ones at you like this to try to trick you, it might help to draw underneath it the number of lines based on the exponent. That is a visual to help you know exactly which ones are going to combine together. You don't have to do that. That's just if you start getting anxious because there's so many of them. And then you would combine it. You've got negative 6b to the 4th minus 4b to the 4th. Notice the variable and the exponent do not change when you're adding and subtracting. It's like the last name. Then we have 2b cubed plus b cubed. And then we have 8 plus 1. So that's adding. Subtracting is the exact same concept with one step in the very beginning, and that is this negative 1 needs to be distributed to everything after it, which means it's going to change all the signs. Only of what goes after it, though. The stuff in the front would stay the same. This would become negative 3 plus 8x squared minus 3x to the fourth. 4. Oh, that was terrible. And then you would go through and find your like terms and combine them. I would start by looking for the highest exponents, and then that way you know what needs to slide to the front. So negative 3x to the fourth. Then we have 5x squared plus 8x squared. There's no like term with the x, so you just copy it. And then negative 5 minus 3. It is positive 3. I don't know who I'm talking to, but someone in this area asked. It's positive 3 in the parentheses. So when you multiply that by that negative 1, it's going to become negative 3. It's going to change the sign. Multiply. If you look, 7 through 12 are all multiplying a binomial times a binomial. I'm going to show you. Does anyone use the box method? 1, 2, not a problem. 3. Okay, I'm going to show you 2 methods for multiplying. The first method is the traditional box method, which means you would need to have spaces, the number of rows for the number of terms, and then the number of columns for that number of terms. And it does not matter which one you put where. If you don't know the box method, or if you choose not to learn the box method, there's nothing wrong with you ignoring me right now. So I'm going to write 4m plus 7 across the top and 8m plus 6 down the side. The box method is helpful to organize your work. If sometimes your work gets chaotic and then that causes confusion, you are now going to multiply by just taking your eyes or your fingers and just saying to yourself, 8m times 4m is 32m squared. Then 8m times 7 is 56m. 4m times 6 is 24m. 6 times 7 is 42. Then you look for the diagonal of like terms. So like right here, these are like terms. So when I go to write my final answer, I would combine those. So the answer is 32m squared plus 80m plus 42. So that's the box method. The alternative method practice, yeah. The alternative method is FOIL. First hour intervals. Yeah. So I need you, if you use FOIL, I need you to listen. FOIL only works when it's a binomial and a binomial. That's the only time it works. When we get a binomial and a trinomial, FOIL does not work. So be ready for that. Be ready to know when not to FOIL. Okay? So now I'm going to show by the FOIL method. I didn't mean to write it right above it. So I'll write it over here. FOIL. And then I want you to make a note. Only with bi times bi, meaning binomial times only time it works. So what is FOIL? FOIL is saying the first element times the first element within the parentheses, the outer elements, the inner elements, the last elements. And then you visualize multiplying those and you write what you get. So first times first, outer times outer, inner times inner, last times last. Then you combine the like terms that are in the middle, these two. What is that, 12? There will be times when I will say the fastest way to go here is FOIL. There will be times for that. So it is helpful, but it's kind of one of those double-edged swords. You have to know when you can use it. I really hate when people get multiplying wrong because they try to FOIL every single one of them, and I've thrown a binomial times a trinomial at them, which means they're going to get part of it wrong. So just know when to use it. There's a third technique. I'm going to show it to you. It is called the distributive property. The beauty of the distributive property is it works every time. Doesn't matter what you have in front of you. You can have a monomial times a binomial. You can have a binomial times a binomial. You can have a binomial times a trinomial. Doesn't matter. You can have a trinomial times a trinomial. The distributive property works. The idea is you take the first set of parentheses and you split the terms up. You split them up, and then you repeat the second set of parentheses. So I've nicknamed it split, repeat. Okay, I call it the split repeat, or you can call it the beat repeat. If you don't want to learn this, you don't have to, but you're going to hear me say it a lot, and you're going to see me write it a lot. So, and remember, it works when we get to the binomial times the trinomial. Split repeat. You're going to take the first set of parentheses, and you're going to split them apart by the terms. So we have 8x, beep, plus 5, beep, and that's where you see the beat comes in. So the beat is where you repeat the second set of parentheses. This is what repeats. So 4x minus 2, 4x minus 2. What you've just done by doing the distributive property like this, you've just taken a binomial times a binomial, and you've rewritten it as a monomial times a binomial. That's the beauty of the distributive property if you go this route, because now, piece of cake, this goes in here, this goes in here, and then I combine the terms that are alike. So we have 32x squared minus 16x plus 20x minus 10, like terms in the middle. And like I said, it works every time. When we get the binomial times a trinomial, you would take the binomial if it's first, whatever's first, or you can switch it. Remember, multiplication order doesn't matter. So you take the binomial and you'd split it up, and you would take the trinomial and repeat it. And then you would have a monomial multiplying into a trinomial. And this is
We'll show us that one.
absolutely. Does someone have a question?
Do you know parentheses are about the 32x squared plus 4x minus 6?
No, that's my answer. Yeah. I'll show you the distributive property again, the beat repeat, split repeat, whatever. So here we go. Multiply that times that. If you need to separate, draw the line to visualize. So I'm going to write it 6r beep, minus 5 beep. And then in the beep, I'm going to write 7r minus 7 twice. Then you would multiply. 42.
Do we need to pull a common factor out of these?
No, not yet. Who asked that? Not yet. It's all 17. So if you go to 17 on the back,
Here, you did good.
what's the difference on 17?
It's square. So
Please, please, please do not square everything in there. That's not what that means. There's multiple terms in
That
here.
means multiply
I know
16
your time, I
minus
know.
7
Thank
minus
you.
16 minus 7.
Thank you.
That looks like 66, Miss Holcombe.
Hey, how about you let her do our work?
Pierce? Sorry.
He does. I'm sorry. Sometimes the 6 and the B do blur
Okay,
together.
I think that was.
Now we're on this, are you ever going to get mad, like, if we're on a test and we, like, if you put a B in there, can we change it to an X as long as we, okay.
Yes. When we get to my math lab, no.
No?
And it will count as wrong.
But, like, you know, papers and stuff that you grade
For
yourself.
me, that's fine. I
Okay.
understand.
Okay.
Yeah. I want to give you the answers to the 4 factoring questions. Because I know you just can't stand it.
I just can't stand that I did that all wrong.
Let me tell you real quick that this sheet is division, right? But we don't call it dividing polynomials. We say
Factor.
factoring polynomials. I gave you one of each type. This is a difference
Of
of
squares.
squares.
I don't care.
This has a initial GCF. I should have given you a perfect square, but I didn't, but that's all right. This is just standard, and this is a sum of cubes. There's also difference of cubes. I'm going to give you notes on that tomorrow. Difference of squares. They both have to be perfect squares, and it has to be minus.
Uh-huh. You can't have it.
Has to be. So this is the form. I'm going to put PS for perfect square. It's perfect square minus perfect square. That's a difference of squares. It factors to, it's beautiful, the square root of both. And because there's a difference in them, one's plus, one's minus. Order does not matter there. You could have written the x minus 9 first, x plus 9 second. Doesn't matter. This had an initial GCF of what? 3. You just divide it to the front. It does not disappear. It's still there. It just goes to the front. You would end up with this. And then this is a standard factoring problem where A is 1. If you don't remember how to do it, I'll give you notes tomorrow. This factors to this. Again, the order of the parentheses does not matter. They could be transposed. This is an example when A is not 1.